that AC is bigger than DF. Moving on, number 2. The measure of HGI and the measure of IGJ. Got it? They're equal. Why?
Because they are congruent.
Very good. They're congruent triangles because of side, side, side. And this angle needs to be congruent to this one. So they are definitely equal. What about number 3? Number 3. Janelle? Less than. Why?
Because 1 is with the 11 and 2 is with the 14.
Very good. The angle for 1 is opposite a side that's 11. The angle with 2 is opposite the side for 14. Now, the other two sides, do you see how they're equal to each other? That has to be there in order for us to make that conclusion. Okay? Number 4. Emma?
Less than.
Why?
Because angle K is 35 degrees and it's across from MN, and 19 is across from KL, so you know that KL is less than MN.
Very good. KL is opposite the angle of 19 degrees, and MN is opposite the angle that is 35 degrees. Okay? Now, we are only given one side that's the same. What's the other side that's the same? Mariana? The middle one, okay? Because it's shared by both of them. Awesome. Any questions on the warm-up? Gucci? Okay. Now, your midterm review. All right, Chapter 7, Section 1, Angles of Polygons. All right, so the parts of polygons. Each segment that forms a polygon is a side of the polygon, okay? The common endpoint of two sides is a vertex of the polygon, and a segment that connects any two non-consecutive vertexes is a diagonal, okay? Super complicated, but when you think about it, it's not that bad, okay? So all of the red marks, do you guys agree? Those are sides of the polygon down below, okay? The blue dot is a vertex. The number of vertices is going to be the same as the number of sides. So there's a vertex at B, there's a vertex at A, there's a vertex at E, and there's a vertex at D, okay? Now, do you see that green line going across your polygon? That is what we call a diagonal, okay? There's another diagonal in this image, and it would go from D to what letter? A, okay? It's any segment that goes from one vertex to a non-consecutive vertex, okay? And by consecutive, that means like it's next in line, right? So do you see how D and C, that just forms a side of the polygon, not a diagonal? Because C is also the next letter next to D. Same thing with E, right? So in order to draw a diagonal, you can't go to C, you have to go to B, or you have to go to A. You have to go through the polygon.
So basically just the ones that are because all the other ones are going to be sides.
Correct. All the other ones are going to be sides. So D to E would make a side, and D to C would make a side. But DB and DA are your diagonals, okay? What about E to C? Yeah, that would be another diagonal, E to C, okay? E to A would also be a diagonal, but I'm sorry, C to A would also be a diagonal, but remember, it was asking from D, okay? All right. So now, there are some names of polygons that you guys need to have memorized, okay? You can name a polygon by the number of sides. Obviously, if you have a 3-sided figure, it's called a 4-sided, 5,
Pentagon,
6,
Heptagon,
7,
Heptagon,
8, 9, 10, and 12. Dodecagon, okay? Now, if you have anything 11 or 13 and above, it's going to be an n-gon, okay? So let's say you had 11 sides, okay? That would be an 11-gon, okay? Let's say you had a 13-sided figure. That would be a 13-gon.
Oh, but that sounds wrong. But it's not.
It's not wrong, okay? So if you have anything from 11 or 13 and above, it's going to be the number of sides gone. So 13 gone. What would be a 20-sided figure? A 20 gone, okay? What about an 1,000,000-sided figure? A million gone, okay? You'll never see it. Okay. All right, to find the sum of the interior angle measures of a convex polygon, draw all possible diagonals from one vertex of the polygon. This creates a set of triangles. The sum of the angle measures of all the triangles equals the sum of the angle measures of the polygon. Now, that sounds super confusing, okay? But let's take it one step at a time. We have a triangle in our first image, right? How many degrees are the interior angles of a triangle equal to? Gabby? 180. So put a big fat 180 inside that triangle. There's 180 degrees to deal with. A quadrilateral, okay? That's a four-sided figure. Do you guys agree that from this point down in the bottom left corner, there's only one diagonal that we can draw along that dotted line, okay? That separates our figure into how many triangles? Two. So the degrees of a quadrilateral are 180 plus 180. What's 180 plus 180, Gabby? 360. Yes, but remember, you only go from one vertex. Okay? That's a great point, Gabby. Gabby said, well, couldn't you also draw a diagonal this way? But do you see how that's starting from a different vertex? Okay? It has to start from the same vertex. Okay? Christian, what's your question?
Google said that a million-sided polygon is
A megagon.
It's like a circle.
Told you.
I was wrong, guys. A million-sided figure is a megagon, okay? But you won't need to know that for your test. Okay.
That's extra credit.
Yeah, maybe. I like that.
Actually, please.
Okay.
Like, I need that.
Pentagon. How many triangles are formed from the diagonals of a pentagon? There's 3. So it's going to be 180 plus 180 plus 180.
So every time I make a triangle.
How many degrees are the interior angles of a pentagon going to add up to?
Like 40.
Giselle? 540, baby.
Girl. I was thinking a guess. What did you say? 40. I was thinking of like 1.
What about a hexagon? It's going to be 180 plus 180 plus 180 plus 180.
840.
Not 840. Come on.
I guess.
Come on. Yep. 720.
I said 7.2, guys. I was good.
Oops.
Oh, that makes sense.
5 minus 2 gives me 3. You multiply that by 180. So in other words, if you have an n-gon, which is n sides, you take n, you subtract 2. That's how many triangles are going to be inside. And then you multiply that number by 180.
Oh.
So let's say we had, I don't know, let's say, go ahead and down below, right, that we had a 7-sided figure. Okay? What would be the number of triangles inside our figure? 5. Then we do 5 times 180. And I should get what? What? I think it's 900. Okay, 900 degrees.
Oh, that's pretty easy.
Can I still write the 180?
Yeah, you can still do that. 5 times 0 gives me 0. 5 times 8 gives me 40. Bring up the 4. 5 times, yeah, 900.
That sounds really odd.
But how do we...
What sounds really odd?
180 times 5.
Convex n-gon is called n minus 2 equals 180. That is our polygon interior angles theorem. Do you need to know that? Yes. Okay. Now, there is a corollary to that theorem, and it says the sum of the measures of the interior angles of a quadrilateral is 360. Okay? Because we're going to be dealing with a lot of quadrilaterals, and a corollary, you don't remember what a corollary is? Okay? No, it's not a converse. Okay. Corollaries are just smaller theorems from a bigger theorem that you use a lot, right? So, do you guys agree that a quadrilateral is a polygon? So since we're using quadrilaterals a lot, right? Quadrilaterals are 4 sides, right? So if we do 4 minus 2, we get 2, right? We multiply that by 180. How many degrees are inside a quadrilateral? 360. The corollary 7.1 is just saying you're going to need to know that quadrilaterals have a sum of interior angles of 360 because we use them so often. But you could have just used your formula n minus 2 times 180 and figured that out every single time.
So wait, what's the difference between the corollary and the theorem?
The corollary is specific to quadrilaterals. Okay?
Wait, a polygon is all closed figures.
Correct. Mm-hmm.
Quadrilateral is only four.
So polygons like pentagons, hexagons, all of them, right? Quadrilateral has to have 4 sides. Okay? All right. Let's do an example. The measures of the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Find the measures of all the interior angles. What do you think we would have to do for this problem?
Oh, I know. Do you add all of them?
Yep.
360 divided by 4.
Wait, what is going on?
The last slide. Wait. There's so many slides.
What do you guys think we do for this problem? Well, first of all, Xavier, what do you think?
You first you combine all the like x the measures and then it equals like 360.
Why did you do that?
Because there's 4 angles, so there's 4 sides.
Very good. It's a quadrilateral, right? So it has 4 sides, n equals 4. So we know that it has to be n minus 2 times 180. That's going to be equal to all of the angles added together. So x plus 3x plus 5x plus 7x equals n minus 2 times 180. This on the left is going to give me, what, like 16x?
I knew it.
Equals n minus 2, which is going to be 2 times 180. So 16x equals 360. That's where our corollary comes into play. You divide by 16, divide by 16. And yes, you're going to have to divide by 16. So you have to do 360 divided by 16. Okay, so we divide by 16. 16 goes into 36 exactly 2 times. You're going to subtract 32. You're going to get a remainder of 4. Bring down your 0. 16 goes into 40. I believe it's, no, it's not an even. I think we're going to use 2 again. Minus 32. Oops. Skipped. Okay, minus 32. Did I do something wrong?
No, it's 22.5.
4 plus. And then bring down the 0. 16 goes into 80. 5 times? Minus 80 brings us 0. So x equals 22.5. No, don't round it. Yeah.
What happened to the end? Exactly. Those are I'm confused. That's why I couldn't.
So how many sides is a quadrilateral?
4. Oh, okay. So that doesn't make sense because I was like.
Okay. So now x is 22.5. So I know one of my angles is 22.5. Okay. That's x. The other angle is 3 times 22.5, which is going to give me, I think, like 67.5. So one angle is going to be 67.5 degrees. The other angle is going to be 5x. So we're going to take 5 multiplied by 22.5. We're going to get 25. Bring up the 2. 2 times 5 is 10. Plus 2, 12. Bring it up to 1. 5 times 2 is 10. Plus 1, 11. So 112.5 degrees. And the last angle is going to be 7 times 22.5. 22.5 times 7. It's going to be 7 times 5 is going to be 35. Bring up the 3. 7 times 2 is 14 plus 3. It's going to be 17. And then 7 times 2 is 14 plus 1, 15. So 157.5. Okay, so anytime it's asking for the interior angles of a certain sided figure, okay, use the formula n minus 2 times 180. Because you need to find all of the angles added together inside that figure. So the measure of all the interior angles are 22.5 degrees, 67.5 degrees, 112.5 degrees, and 157.5 degrees.
You have to add them?
Nope. If you added them, what would you get?
Oh.
360, okay? You can check it. Cool beans? All right. Equilateral, equiangular, and regular polygons, okay? Now, when we were talking about triangles, equilateral and equiangular, they meant the same thing, right? Well, not necessarily the same thing, but they were true for all triangles, right? If a triangle was equilateral, it had to be equiangular, right? That's not true for all polygons, okay? So, take a look at this figure. Do you see how all the sides are the same? Are all the angles the same measure? No. Do you see how this angle is clearly smaller than this one? Okay. Same thing. If all the angles are equiangular for a polygon, do all the sides have to be the same? No. Okay. So triangles were a different story. A regular is what we call a regular polygon. It is both equilateral and equiangular. Okay. So triangles, if they're equiangular, they have to be equilateral. But for regular polygons, okay, they have to be a regular polygon in order to have both, okay? Otherwise, they can only have one or the other. All right? So equilateral means all sides are congruent. Equiangular means all angles are congruent. When you have both, all sides and angles are congruent, we call that regular, okay? In other words, you'll see like regular, quadrilateral used often. Does anyone know what the regular quadrilateral is? What shape that makes?
Square.
Xavier?
Rectangle.
Not a rectangle. Are all sides the same on a rectangle?
Square.
A square. But I wanted you to raise your hand,
Oh,
Emma.
I'm so sorry.
It's a square, okay? So a rectangle has all the same angles, right? But remember, for a rectangle, it's possible that two of the sides are different than two of the other sides, right? So that would make it not the regular quadrilateral. All right. Theorem 7.2, Polygon exterior angles theorem. So what this says is the sum of the measures of the exterior angles of a convex polygon is 360, okay? Doesn't matter the amount of sides, doesn't matter anything. If you add up all of the exterior angles of a convex polygon, it will equal 360 degrees. In other words, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 equals 360. Now notice each of those red angles lies outside the polygon. Do you guys see that? That's because they're exterior angles. The interior angles for this polygon, which is a pentagon, it has 5 sides, added together will not give me 360, okay? They'll give me 520. I'm sorry, 540. Those are the interior ones. In a regular polygon is n minus 2 times 180 divided by the number of sides. Keep in mind, it has to be a regular polygon, okay? Now, a regular polygon means that all of the sides and the angles are the same, okay? So that's why we can just take the sum of all the interior angles and divide it by the number of sides. Because that'll give us the measure of each interior angle. Now, there's another formula for regular polygons for the exterior angles. okay? And we're going to come up with it together. So, regardless of the number of sides that you have, what is the sum of the exterior angles of a polygon? Gabby? 360. Okay? And then what should we divide by to tell us each exterior angle of, say, a 7-sided figure? Yeah, the number of sides. In other words, 7, or, just to be more generic, you divide by n, okay? So the exterior angles of a regular polygon is 360 divided by n. Now, you can only use these two formulas for what kind of polygon? A regular one, okay? If it's not a regular polygon, that means that all sides, all angles are the same. You can't use this formula, right? Because you could have completely different angles for each of your angles and completely different sides for each of your sides. Classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. All right, we're getting into the examples. So, for the first one, how can we classify the polygon? What's the name of it? It's a hexagon. Very good. Okay. Why is it a hexagon? 6 sides. Is it regular?
Yes.
Yes. Why is it regular? Very good. All the sides are the same length and all of the angles are the same length. Okay? Or the same measure. It's regular. All sides plus angles.
Was the AirPods case left in here?
Anna, did you see an AirPods case by your chair? No, I don't think so. I didn't see one either. Sorry, Sheila. If I see it, I'll let you know. All sides and angles are the same. What about B? First of all, what kind of figure is it?
Quadrilateral.
It's a quadrilateral. Is it regular?
No.
Is it equiangular?
No.
Is it equilateral?
No.
No. Not I'm just going to put anything. It's not anything. Okay? Because do you see how the sides, they're not all the same length? And the angles definitely are not the same measure. Okay? What about C?
They all look the same.
Xavier?
It's regular.
It is regular, okay? Because all of the angles are the same. But is it...
Oh, it's the other convex, concave.
No, it's concave. I know.
This is concave. Very good. So it's concave.
I know, they were doing
Okay?
It's
It's
dodecagon.
a dodecagon. Because it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. Wait, Xavier, you said it was regular?
Yeah.
It is not regular.
How? Everything's the same.
They're all the same.
Take a look at this angle.
Is it because the writing was outside of it and not?
Very good. The right angle here, do you see how it's outside the figure? It is not a regular polygon, okay? Because this angle inside is actually 360 minus that 90 degrees. So it's 270 degrees, okay? So not all the angles are the same, okay? So it's not regular. It is what, though?
Equilateral.
It's equilateral, because all the sides are the same length.
But we weren't doing concave.
That was a tricky one.
That was a tricky one. 2. What are the sum of the interior and the exterior angles of a heptagon? Well, first of all, how many sides does a heptagon have?
7.
So, n equals 7. So what's the sum of the interior angles? Yeah.
I don't know.
Yep.
60.
Nope.
Oh, wait, no.
5 times 180.
Yeah.
Why is it 5?
Because you have to subtract 2.
Very good. It's going to be n minus 2 times 180. This is interior. In other words, it's n minus 2, which is 7 minus 2, times 180, which is 5 times 180, which we said was what? 900?
Yeah.
Wait, wasn't that?
Now, what is the sum of the exterior angles? Xavier? Nope. 360. Does it matter what the number of sides is? No, it's always 360, okay? The exterior angles will always add up to 360 degrees, regardless of how many sides you have. So, let's just jump to the exterior angles for a 17gon. How many is it?
17 sides.
Yep, it's got 17 sides. So what's the sum of its exterior angles? 360. Now, what's the sum of its interior? Well, we've got to do n minus 2 times 180. That's going to be 17 minus 2. Multiply that by 180. And we're going to get 15 times 180. And we're going to have to do it over here on the left. 180 times 15. Oh boy. 5 times 0 is going to give me 0. 5 times 8 is going to give me 40. Bring down the 0, bring up the 4. 5 times 1 is going to give me 5. Add 4, you get 9. Bring down a 0. 0, 8, and 1. You're going to get 0, 0 degrees. What was your question, Issa? Yeah. What if I zoomed in? Did that help? Okay. Uh-huh. Some of it. There's like 1 or 2 questions that is going to be like, of the polygon, okay? Now, the only of the polygon, the sum of the measure of the interior angles of a convex polygon is 900. Find the number of sides. How do you think we would do it, Gabby?
It's a heptagon.
No.
What? Okay, wait.
Okay? Well, we know that the sum is 900, right? We should set that equal to what?
180? No.
360.
Something to do with 180. What don't we know?
N minus 2. Yeah, 2 equals 900.
So n minus 2 times 180 has to equal 900. Do you guys agree?
Yes.
So what are we going to do to solve for n? Because that's what we need to figure out.
Subtract 180.
Don't subtract 180.
Oh, JK.
Oh, you can distribute. You can distribute the 180. And you would get 900 equals what?
180
180
and
180 minus 360.
180n minus 360. What do I do from here? Add 360 to both sides. Plus 360, plus 360. What am I going to get on the left?
1200.
And on the right? Mm-hmm.
And then you have to divide.
By 180. All right, here we go. 1,260 divided by 180. Now, 180 does not go into 126, so we're going to start over here. Who said 7? Did someone say 7?
It's 7?
It is 7, okay?
I said 7?
So it's going to be 0, 6, 2, 1, and it's going to be 0. You said a heptagon.
No. I said heptagon.
Oh, I misheard you, okay? It is a heptagon, n equals 7. Now,
Bro, what an
Lauren said to distribute first, right? Instead of distributing first, my recommendation, okay, so that this number on the left does not get too crazy, is to just divide right off the bat by 180. Okay? Because then 900 divided by 180 is 5, right? So you're going to get 5 equals n minus 2, and then you would just add 2 to both sides, and you would get n equals 7. Okay? Regardless of which way you do it, since they're both algebra, like, we're fine, we're not committing an algebra crime, okay? We're going to be okay, and we're going to get n equals 7. But I personally believe that the writing on the in red is a little bit more complicated when you distribute first. If that's just how your brain works, then keep doing that, okay? All right, any questions? We're almost there, guys. Wait. Okay. Find the measure of each interior angle and each exterior angle of the given polygon. A regular quadrilateral. What would be the measure of each interior angle? Well, we know the sum is 360, right? But how would we find each angle? Xavier? Divide by 4. Why can we divide by 4?
Because it's 4 angles.
Yeah, but why do they all have to be the same for this? It's regular, okay? So we divide by 4, and we'll get, each angle must be 90 degrees. What about the exterior?
360. Because all exterior angles are 360.
Yep, it's going to be 360, and then we divide by 4. So each exterior angle also needs to be 90 degrees. An octagon, a regular octagon. Well, how many sides is an octagon? 8. So we're going to do 8 minus 2 times 180 over what? 8. 8 minus 2 is going to be 6 times 180 divided by 8. I wouldn't do 6 times 180 yet. I would start to cancel stuff out. So 6 cancels with 8, right?
Yeah.
What's a common factor?
2.
2. So this becomes a 3, and the 8 becomes a
4.
4. Does 4 go into 180?
Probably.
Probably. I would just take out another 2. So this becomes a 2. 180 divided by 2 is?
90.
90. Is 90 divisible by 2?
45.
Yeah, 45. And this becomes a 1. What's 3 times 45? I think it's like 135.
Just like 112.
Yeah.
What did I just do? I just canceled. If you want to multiply 6 and 180 and then divide it by 8, by all means, do that.
18 times 6 and add 0. Boom. I crossed it out.
Okay, now the exterior is just going to be 360 divided by
8.
8.
So is it the interior and exterior the same for all of them?
No,
Just the exterior. All the exteriors are 360.
correct. Mm-hmm.
Oh.
Because each of them has a different shape, right? It has a different number of sides.
Yes. Oh, yes.
Did anyone do 360 divided by 8? 45. Now, do you notice anything between the exterior and the interior angles for each shape?
I said like when you multiply 45 times 3 and then that one's 45 also.
Okay,
They're both like 45, like in like
kind of.
It would have 180, right?
90 and 90 add up to?
180.
oh
135 and 45 add up to? 180. All interior and exterior angles should add up to 180, okay? Let's keep going. We're almost there, guys.
Wow.
What about a regular 15 gon?
Does it not matter if it's
15 minus 2 times 180 over 15. This is going to be 13 times 180 over 15. Okay, so 13 times 180 divided by 15. I know that 15 goes into 180, like, two, I think it's like, 12? Yeah, you're right. And then 12 times 13. Yeah, and then adding together, they add up to 180. Very good. Okay, a regular 20gon. I know. So 18 times 180 over 20. Someone do that for me.
Okay, so we're just what times 180 divided by
20.
20 equals 162.
162 degrees. And then the exterior is going to be 360 over 20. Oh, that one should be easy. I think that's just 18. Perfect.
Can I put it in now?
No.
Wait, what?